Okay, so first let's start from the beginning about a programming language. Okay, so as we communicate with each other, to our friends, to our relative, to our colleagues, we use a language so that we can understand their feelings, their emotions, anything. But when we try to communicate with a computer, we need a programming language. So we can say that programming is a way to interact with computer to perform various tasks. So previously what we were just the users of the computers. Now when we are just learning a programming language, we are creating some applications so that we can perform various tasks. Like what kind of applications we can create? We can create a to-do app, a web application, a desktop applications so that it can benefit other users of computer. Now moving to the second slide about high level language and a low level language. So high level language are the human understandable languages that are easy to read and easy to write. So the examples that are like C, C++, Java, Python are the most common examples. Considering to the real life examples, there are languages like English, Bengali, Hindi, Spanish, and other languages. So you use these languages so that it can be understood by other people easily. And what are the low level languages? Low level languages are the machine level languages that can only understand binary forms. That is only zeros and ones. And it's hard for users, right? Hard for humans to understand it. Suppose I say you like 1010, and if you do not know the binary calculations, it will be hard for you to depict the what I meant to say, right? So in the real life example, it's the similar kind of Morse code. So Morse code is like a dots and dashes, and it's used for transmitting some kind of message during the words. So have you heard about Morse code, Asna?
Yes, sir, I've heard about it.
Okay. So Morse code is like a device and it can produce dots and dashes. Like no, long sustainable are the dashes and for a short intermittent are the dots. So what is the key idea that we are going to depict here? That's human writes in high level languages and computer translates it into machine understandable binary. Just want to say in between that when you are just going from high level language to the low level language, there is a intermediate state is there that is done by a component called as assembler, and that is called as assembly language. Assembly languages, you can say it's understandable by the processors, the microprocessors that we have in our CPUs, right? So that is the main concept in this slide. Any queries up to this point?
So can you repeat the last part again?
Okay, when you are just traversing from high level language to machine level language, there is a mid component is there. So what is the mid component that we represent there? That is called as assembly language. Remember, assembly language. So what are assembly language? These languages are generally understood by our microprocessors. Okay, so in our first day, when we were just discussing about the computer organization and architecture, we heard about this term assembly language. Suppose in 8085 microprocessor, if I write something as MOV, MVI, these are the commands. MOV is for moving and MVI is also for moving from one register to another register but with immediate to the accumulator. So these are the things that is the function of a assembly language. Then it converts into the machine level language, that is the zeros and ones. So this is the flow, this is the workflow that goes from high level language to low level language. Is it clear now?
Yes, sir, it's clear.
Okay, great. Now, here we will discuss about some Morse code just for our understanding that Morse code is generally encoded, means it encodes our alphabets so certain kind of dots and dashes. It is similar to a low level language because it can't understand by humans, and it maps human readable instructions into a simpler form that a computer can execute. Here I have depicted one example called as welcome, and here you can see that dot dash dash that corresponds to the alphabet W. E is single dot. So this way we can structure the complete word as welcome. Now moving to the next slide about the compiler. So what does the compiler do? As you can see, a chef who is making a cake, he adds some kind of ingredients to it. What are the ingredients that he puts into it? Such as he mixed flour, sugar, eggs, syrups, vanilla flavor, and everything that is available into that mixture, and he bakes it to make a cake. So, what's our motto here? From the raw components to make a final or finished product that we do. So, what does a compiler do? So, compiler is a software that translates code from a high level language into a low level language, and it translates the entire program at once. And if there are any errors, it will show into your console, all of them at once. The debugging sometimes becomes difficult because multiple errors appears all at once. These are the lines that the errors occurred, and it will show you onto the console. The program that is given at the input side into the compiler is called source program. Once it's processed by the compiler in machine level language is called the object code. So if someone asks you that how a compiler is analogous to real life, you can say that compiler is like someone who translates the entire book before you can read it. Or you can say that suppose your parents who just read the complete book and brief you out what is the moral of that story. So that's the work of a compiler. Is it clear now?
Yes, sir, it's clear.
Okay. Now we will learn about functions of compilers. So this is important to learn about the functions of the compilers because compilers perform some kind of functions, like some kind of task you can say. What are the tasks involved into it? One is lexical analysis, that is breaking the sentence into tokens. Suppose you have written that I read in class 11. So it will break these words into tokens like I, then read, in class 11. So this they will split these words into tokens. So into a real life example, like add 2 cups of flour that I have written in my slide, means Lexer splits into add that can be termed as keywords. 2 is the number, cups is the unit, and flour is the ingredient. Okay, got it this point?
Yes, sir, got it.
Okay. Now comes to the syntax analysis. Syntax analysis is the grammar check. That is, if I write something as a, suppose in some language a int equals to 10. It is not a correct grammar. We need to write int a equals to 10 in case of C language. So we need a proper grammar to be implemented, that is called as syntax analysis, and it should be on the proper order. If the order is not correct, it will show as syntax error. Now comes the semantics analysis. Semantic analysis means the sentence or the code you have written makes a complete sense or not. Like you have written that add 2 cups of pulses. So when we are making a cake, I think we are not interested about pulses or dal, right? We are just interested on flour, maybe butter, maybe something other else. So it should make a complete sense. So we need to remember that if the grammar is fine, but the semantics should be correct. As I have written in this example that add 2 cups of sunshine is not a valid semantic. That causes semantic error. Now next comes the step as optimization. Means how can we make it better? Now if we just concentrate on the real life example, that step 1 add 2 cups of flour, and in the second line we write add 2 cups of flour. So this two line compilation we can optimize, such as add 4 cups of flour once. Optimization means in a short term you can say that to make the a good proportion of time complexity to be a better one, that it should not take maximum time to get that output. It should give us the output in minimal time. Now comes this last step, that is the code generation. That is finally that we translate the instructions into a form that machine can easily understand. So that's all about the functions of compiler. Any point up to this?
Okay,
Any
sir.
questions? Okay, okay.
Uh,
Okay, now comes about interpreters. Interpreters are live translators. So you have seen in television or any media channels, like if when two prime ministers of different country visits a seminar or a conclave, so there is an interpreter in between. In our Rajya Sabha or Lok Sabha, there is also an interpreter, so that he can translate the instructions, the sentence, once he has spoken out that language. In this example, suppose a someone from India visits Japan. It's not possible to him to understand the Japanese language. So he might need a interpreter who sits in the middle of this person. So suppose I say bye bye, and the interpreter process that line, and he says that the person wants to say you sayonara. Maybe I'm not equipped with the Japanese language, but I am providing it as an example. So interpreter translates every sentence as is spoken, so the conversation flows line by line. And if a sentence doesn't make any sense, the conversation would be terminated. So this is just like a code execution line by line. Okay.
okay, sir.
Yeah. Okay. So you know this person as Guido van Rossum, who invented Python.
Yes, sir.
Okay. So these are the terms that we have already covered. I am not going through them. So I just want to discuss this slide with you. That is, Python is both compiled and interpreted language. Why it's both compiled and interpreted language? Let me give you an overview of it. Suppose I have written one program of adding two numbers, then it passes through the compiler. That is again that four functional steps of compiler would be taken place. What are those? Lexing, syntactical checking, and semantic checking. Then compiling. Then it will be transformed into byte code. That is the intermediate code, and it is written as .pyc in Python. Then it will be interpreted. Who will interpret it? It will interpret by Python virtual machine, and it will convert it into machine code, and what the processing will take place, and we will get the desired output of that running code. I am giving a 1 minute pause in this. Let me know if you have got this concept.
So can you repeat again?
Okay, fine. Suppose you have written a program of adding two numbers, and that is the source code because you have written that program, and the input to the compiler is called as source code. Once the compilation is done, it's called as object code. So in this example, we have written a code as abc.py. Next, it will pass to the compiler. Compiler will perform the four major steps that we have discussed in our previous slides. That is lexing, means breaking down of the words into tokens. Tokens are the most minute or atomic element in any programming language. So it will check whether this is a keyword or not, this is a literal or not, this is any variable or not. So it will break down into tokens. Once the tokens are broken down, it will check for syntax analysis or syntactical checking, that whether the grammar is correct or not. Once it's checked that grammar is correct, it will check the semantics are correct or not. If the semantics are correct, it will go for code optimization and generate the low level code. That's the structure of compilation, and it will form a intermediary code that is called as bytecode. That bytecode will be interpreted by Python virtual machine, and it can be ran, and the output would be processed by our microprocessors, and the output will be displayed in our console.
Okay, sir, it's clear.
Okay. So, just to remember that bytecode is a platform independent representation of our code, means it can run on any version of operating system, be it Mac, be it Linux, be it Windows. And
Okay,
just
sir.
just let me know if you have any facing some issues while understanding this. Okay, there is no issue.
Yes, sir, sure.
Okay. Features of Python we have already discussed in previous class. I'm not going through it. Installing Python and PyCharm, Python essentials. Execution modes we have already discussed. These are the comparison between interactive mode and script mode. So Python characters, sets, and tokens. As I said, the character set is Python leverages ASCII and Unicode. And previous we have uh, did the lexicographical analysis of two words, that is car and cat, which one is greater. Tokens are the building blocks, and there are multiple tokens that can be there, like keywords, like result words, if, for, while, class, false, assert, race. So these are the keywords. Identifiers are the name for the variables. As I said, that it's just like a label on the name. You remember, right? The example that we discussed previous day on
Yes,
identifiers.
I do.
Okay, okay, fine. Operators, symbols for performing operations like plus, equals to, greater than, less than. Then there are the delimiters, which are used to structure code, and literals are the fixed values, are the hard coded values. Like suppose a equals to 123, a equals to hello, pi equals to 3.14. And in Python, we have to remember that white space and indentation are very crucial. Otherwise, we will encounter error. In other languages, indentation are used for beautification purpose, but here in Python, we can say it's one of the mandatory things to be implemented in Python. It's just like a proper syntax or the proper grammar in Python. Without it, it will throw error. Tokenization, just a brief overview of it, like splitting the word into token. In the right hand side, I have just shown an example where we are importing one package, a standard library package that is known as RE, that is for regular expression, and we are splitting them into via like space and semicolon that you can see in the line statement, and we are printing out the tokens, and it will show us the list of the tokens, a list of the words that are there, like football, cricket, golf, and tennis. So again, a literal is a Python, is a raw value that is directly used in the source code. It's a fixed value, as I said. So string literals are also there, and enclosed in single quotes, double quotes, or triple quotes. Strings can be single or multiple line. There are integer literals. Decimal, there is base 10, binary base 2. In case of when we're writing some kind of binary, we need to ensure the 0B at the start of that binary digits. In octal, we need to write as 0O. In hexadecimal, we can write as 0x. Okay. Please remember these expressions, like where we need to where add, like 0B for binary, 0O for octal, and 0x for hexadecimal.
Okay, sir.
Okay. So these are the numeric literals, Boolean literals, and special literal are none. That is means it's represent null or absence of any values. Okay. Now Ashna, there is a one task for you. In your own language, can you just let me know whatever topics we have discussed till now?
So first of all, we have discussed high level and low level languages,
Okay.
that C++ or Java or Python are high level languages, and which are similar to human languages. Then low level languages are like the Morse code, and the Morse code is a symbolic encoding.
Yes.
And then we have learned about compilers, and compilers compile all the errors all together and represent that at once in the end. Then we have learned about the interpreters, which are like live translators, and which translate the high level languages to low level language. After that, we have learned about the demystify, which is like a symbolic encoding. And then we have learned about the interpreters, which are like live translators, and which translate the high level languages to low level language. After that, After that, we have learned that what is Python, uh, the characteristics of Python, and then we have also learned about the process through which the coding takes place. That is, first it is broken down into tokens, and then after that, uh, grammatics are checked, and then the semantic errors are also checked, and after that it is converted into a machine understandable language, and then the output is given.
Okay, yeah. So that is syntax and semantics. Okay. The grammar check is called as
Okay, sir.
syntax, and the it whether it makes any sense or not, it's called as semantics.
Semantics.
Okay.
Okay, sir.
Okay. So these are the one. Now we will go through this term like one. The Python data types. Okay. So now we have come to a point where we just needs to learn these data types. So first question to you, we have learning this thing for a long. So if someone asks you what are data types, what you will answer?
So data types are the datas that are understood by Python, or
Okay,
Python.
yeah, try.
The values that we enter or assign to any variable that must belong to a specific data type in Python.
Yes, partially correct. So actually, data types means the type of data that a variable can hold. Okay, understand the type of data values a variable can hold. If I
Yes.
said 1, so 1 is a numeric type of data. If I say camel, so it's type of a string type of data. If I said like true, so it's kind of boolean type of data. If I said 5.69, it's a float type of data. If I say 3 plus ij, or 3 plus 4j, that is a complex type of data. So what type of data we represent is a data type. So we should remember that